Welcome to our next video. We're talking about measures of central tendency. We're talking about the geometric mean. If we have growth rates, we need to calculate the measure of central tendency with the geometric mean. The geometric mean here is the teeth root. It's something, and with the exponent of 1 over t, but it's the teeth root of some growth rates plus 1. So we can better understand when using an example, when looking at an example. 6 different years, 6 different value of money on a bank account. First of all, in the first year, you have $1,000 on your bank account. 1 year afterwards, you have $200 more, which means $1,200 on your bank account. In the next year, it's going to be $1,300. In the next year, it hasn't moved up, so it's still $1,300. Then it became less, $1,250, and then to $1,500 here on the bank account. Which means that we have different growth rates. We need to calculate first the growth rates, and then we could calculate the geometric mean, and then with the help of the geometric mean, calculate average growth rates here, or average amount of money on that bank account. So the example is this, and everything else is computation. For example, the growth rate from year 1 to year 2 is this. From $1,000 to $1,200, it's 20%, 0.2, 20% upwards. Then from $1,200 to $1,300, it's 8.3%. Then next year, from 1,300 to 1,300, it's nothing. So it's a growth rate of 0. And then even worse, from 1,300 to 1,250, it goes down, so the growth rate is minus. It's negative. Minus 0.0385, so it goes downwards. The amount of money on your bank account goes down. Then it goes up again from 1,250 to 1,500. It's 20% upwards movement. So those are the growth rates. And we need to calculate now a measure of central tendency for those growth rates. We're talking about the growth rates, and what's the appropriate measure of central tendency? Many people would say, I guess, the arithmetic mean, which is totally wrong. Totally wrong. When talking about growth rates, it would be wrong to calculate the average, the arithmetic mean. Moreover, we need to calculate the geometric mean. Keep this in mind, please. When talking about growth rates, always calculate the geometric mean, but not the arithmetic mean. So, first we calculated the growth rates. Second, we need to calculate the geometric mean. For a growth rate of 20%, it's 1.2. For a growth rate of 8.3%, it's 1 plus 0.0833. So here, for a growth rate of 0%, it's 1.0, which means you always add 1. To every single number here, you always add 1, even here. Minus, if it goes down, you also add 1, which means 1 plus minus 0.0385 gives us 96%, 0.9615, and so on and so on. Which means 5 different growth rates lead to 5 different values here. And since it's 5 growth rates, I mean, we have 6 different years, but we only have 5 different growth rates. So therefore, it's the 5th root, which means the 5th root also can be calculated this way, to have an exponent of 1 over 5. Here, 1 divided by 5. Minus 1, don't forget the minus 1. And then the average growth rate calculated with the geometric mean, as it should be done, as it needs to be done, is 8.4472%. And this is the growth rate that is needed. How can we check this? Let's try to check it. First we need to calculate this, second we calculate this, and the third step is to just check it. So 8.44% from the first year to the second year, starting with $1,000 with 8.44%, after 1 year it's $1,034.47. Again, with the 8.44%, it's $1,176.08, and so forth and so forth, which means, and now, careful, in the last year we stopped with having exactly $1,500. Isn't that cool? Isn't that very, very cool? We ended up with checking that the growth rate, that the average growth rate we calculated is just okay, because it gives us the real amount of money we wanted to have at the end of $1,500. Thank you for watching. Thank you for listening.